Right, so we want to be really good at estimating pH values or pH values. And uh, to do this, we need to look at certain logs, all right? And the log of 10 is equal to 1. And the log of 100 is equal to 2. The log of 1 is equal to 0, all right? The log of zero point 0.1 is equal to -1. The log of 0.01 is equal to -2. The log of 0.000001 is equal to 1, 2, 3, 4, 5, 6, 7, -7. All right. Now this is really important because you'll notice this right here is the concentration of H3O plus and OH negative of water at 25 degrees Celsius. Oh, therefore, to know that these things are and estimate it, it's really important. All right. Now here are my steps. All right, and the easiest to go and do some examples. So look at the exponent and look at the base and then estimate. So let's say my solution had H3O plus, its concentration was 1 times 1.00 times 10 to the negative 10 molar. All right, and I wanted to know my pH. Well, pH is equal to the negative log concentration H3O plus. Therefore, I'm taking the negative log of this. Well, I know that this is just going to be 10. All right. If I take the log of this, that's going to be -10, not 10, -10. Therefore, my pH for this scenario is going to be just 10. So when you look at this, the exponent is your main thing that you want to go by. And since log like compresses numbers onto the scale of 0, 1, 2, oh, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This, the -10, means it's going to be there. All right. Now you also need to consider this. This means 1, so I don't even, so it's right there. It's at a pH of 10. All right. Often what you're going to do with it is you're going to have the pH, and I'll show you in a second. Let's look at a different example. Let's say my hydronium is 8.45 times 10 to the negative. All right. Now, if you put that on here, this is going to be this number with 9 zeros. All right. And that gives you a pH. If I just look at the exponent, it gives me a pH of 10. But I've got this. So that moves me this way a little bit. So my pH will be, for this, 9 point something. To really figure it out, I'd have to do the negative log of this. And I don't know my negative logs by the off my head. So to do this one, it's the power, or the absolute value of the power, minus 1. All right. And then it's this point something. All right. So I take this, I see that, so I'm going to minus 1 from this. It's going to be 9, 9 point something. All right, as I predicted. So in general, the formula is your power minus 1, and that's something. Now, for this one, where my concentration was 1 times 10, or 1, I did it again, 1.00 times 10 to the negative 10th. Here, the 1, I'm not going to be moving. It's exactly at 10. I'm right there. So I don't, my pH would just be 10. I don't minus 1. But I've got, if like this number here at the beginning of the exponent is at a value, that's going to tell you um, to move up. And then your answer is between those two numbers. All right, let's go over a couple more examples. Okay, I've got two examples here. These are two separate solutions. I want to know their pH. All right. For this, my pH, I'm going to estimate it. It's the power of 4. All right, so that's there, but I've got a little chunk of change, so it's got to be 3 something. All right, 3 point blank. All right, and here I've got my pH. Sorry, I've got my hydroxide concentration. I want to know my pH. How am I going to get it? I can't go that through there. I have to get it through my getting my pOH. My pOH should be, the 7 puts me here, but then I've got this, so it should be 6 point something. Now let's do this on a calculator. Let's make this pretty good here. So negative, where's my log? Log of 4.2 second e to the negative fourth. So all right, that's my pH for the first one. 3.37. And I have two sig figs here. That goes into these two. All right. That thing there is the magnitude. It doesn't go into the, that's here. That's not a sig fig. These two would be my sig fig. So that would round to 3.38. All right. And then for this one, I'm going to do negative log of 1.8 second e to the negative 7. All right. I get 6.74. We're once again, for 4, that rounds to this. All right. So those are my values. Hold on. Just for fun, let's see what my pOH would be. It would be 14 minus 3.38. So that's 10.62. All right. And here, my pH is 14 minus 6.74. So that's 7.62. Now, what does this mean? What kind of solutions I've got? Here, my pH, you would go by you can get them from either of them. It, I think we're most familiar with the pH value. This solution would be mildly acidic, and I spelt that wrong because I was looking at what I was writing. And this one is slightly basic. Oh, wee bit, just a wee bit. That's just over 1,0. So it's very, very slightly basic, like a touch, maybe 3 hydroxide molecules in there. All right. And that's how you estimate pH. Just to review, when you're given a pH value, and when you write a pH value, 3.42, these numbers are significant figures. This number is a magnitude value. All right. This number comes from 1 times 10 to the negative 7th. It wouldn't be that. Let's just say it's going to be like 4 something, and I don't remember. Uh, let's just make it like 3.4. I don't know if this is actually going to work. It probably won't. This number goes there, and these numbers go into that. All right. So when you're rounding for sig figs, you don't count the 3 at the beginning of the pOH or the pH. You just round the end ones.